The way this class is going to go is like a learner thought, so I'm going to require your full focus. That's why I prefer you don't use your laptops or phones. And also I'm going to be sharing screen, sharing code, so I would recommend you sit here so you can be able to see without a laptop or a phone.
Can you try stuff related to the class?
Not during the class. Later I have a few things that you're going to be able to try.
Okay.
But yeah. The idea is I want you to be completely focused on me. So, welcome. The reason I'm giving this workshop is because people are starting to use agents right now every day. You can think about something like Cursor or Klein or even ChatGPT. It's an agent itself. And people are building agents as well. And those who use it, they think it's magic. And those who build it, most of them use agent frameworks, and so they don't understand how it works under the hood. So when they fail, they don't know how to debug them, and they don't understand why they fail. And hey, welcome guys. Let's see. So my promise to you is by the end of this workshop, you'll get a clear understanding of how agents work, and it will not feel like magic anymore, and you'll be able to build one by yourself. So I'm going to be doing that by first going over an example of what's an agent, and then we're going to take a step back, see the fundamentals of how large language models are trained, how they behave after they're trained, how to give them memory, how to give them the ability to call tools, and then we'll code an agent from scratch, then we'll do Q&A. So let's go to an example, quick example of a simple agent here. Let's see, agent. Here I have 60 lines of code. Here I'm using the library called Pydantic AI. It's an agent framework library. And I'm instantiating a model here. I'm using Claude Haiku. And this is the agent abstraction that this library gives us. So all of the magic is happening behind this abstraction here. And I'm giving it a tool. And what is a tool? It's basically a function. Here it's a getWeather function, Python function that takes a parameter location, makes a few API calls to get the weather, and returns a dictionary. And if we try this, so if I try, hello, my name is Blake. So if I ask it, what is my name? It will know. So this is the first property that I want my agent to have. I want it to have memory. And the second one is the ability to call tools. So what is the weather in Montreal? Wait a few minutes.
Where is it pulling the data from?
Sorry?
Where is it pulling the data from?
Yes, it's all in this getWeather function, which makes a few API calls to geocoding API and API.OpenMeteor.
Okay.
That's where it does. So those are properties that I want my agent to have. And by the end of this workshop, we're going to be able to code this without the agent framework and without an abstraction, basically. So now, first, we're going to take a step back and think of what is a large language model really. By the way, guys, the most boring part of this workshop is the next 5 minutes. A bit of theory, but then it will be highly interactive. I'm going to be asking you questions and it will be more conversational. So, a large language model, the idea is that it's a deep learning neural network, and it's trained on a massive quantity of text. And it's trained in different phases. There's the pre-training phase, and there's the post-training phase. In the pre-training phase, at first, to give you an idea of how it is trained actually in pre-training, at first we start with a completely random neural network, which means that all the parameters of the neural network are initialized randomly. And what that means is, if you give it the input Paris, for example, the output will be completely random. It will be something like pizza, morning, etc. Yes. So if you go to the Paris Wikipedia page, and its output is a probability distribution, and it chooses which token, which word has the highest probability, basically. And at first, that's how it is. It's completely random, and then we start training it. And for example, if we take the Paris Wikipedia page, and we train it on the first two words only. Basically, what we do in this training step is we show to the model that it shouldn't have predicted the word pizza, and that it should have predicted instead the word is, basically. And after this training step, it will assign a higher probability for the word is, and a lower probability for the word pizza. And so, if we try to think what happens if we train it on this whole Wikipedia page, well, the model will learn that after the word Paris, there's always the word is, has, is again, a comma, is, etc. But we don't train it on only that Wikipedia page, we train it on a massive quantity of text coming from Wikipedia, Reddit, etc. And we can see an example of these data sets that are used for training. So this is an example. It's an open bless you. It's an open source data set called FindWeb, and it's actually used for training open source models. And if you go to this website, you'll see a few snippets of how the text looks, and many other details. For example, how big it is, 44 terabytes. You see how the data gets deduplicated, how it gets cleaned, etc., etc. And if we...
This is great, actually. It's already working now.
Yeah? So, I'm going to be using this app a lot during the presentation, and this helps us see how the text gets tokenized. So if I tell it hello, hello, and hello again, you see that these words get tokenized to these specific tokens, and these two are the same, but the first one is different because it doesn't have a space in front of it. And let's see. After this model is trained on this whole data set of text, what we get is what we call a base model. So we do only the pre-training phase, not the post-training, and we get a base model. And we can see an example of how a base model behaves. For many of you, probably, this is going to be the first time that you see how a base model behaves. And I'm going to be able to do that here. For those of you who don't know, this interface is called the Jupyter Notebook, and it lets you execute code and see the output right underneath. So for example, print hello, I see the output right here. And the library that I'm going to be using is the transformers from Hugging Face. It's a library that lets me load the model completely locally on my computer and run inference on it. Inference is a word that I'm going to be using a lot. Basically, after the model training, you can use the model for inference, meaning just executing it and getting output. So if we let it load for a second. So this is where the interactive part starts. I'm going to be asking you questions and quizzing you a little bit. So the model that I loaded here is Llama 3.1 8B. It's a model from the company Meta. However, this is not the model that you guys are used to. This is a base model. It only went through the pre-training phase. And if I give that model this input, give me a valid email address, what do you guys think the output will be? Or what would it look like?
Just a name, at something.com.
Okay, maybe. Any other suggestions? If there are no suggestions, I'll just run it. Here. It does. It has, mind you, this is a pre-trained model. It has been trained on the whole text on the internet, so it knows what an email means.
You didn't realize it was a question? Like,
Yeah.
just like going, it's like I'm said, it's just continuing the sentence.
No, this also has been trained on some data set where there was that text around the email address, right? So
Well, yes, sure.
Yeah.
Well, let me give you another example, maybe to drive this home. Hello, my name is Malek. So, when I ask this question, when I say this to ChatGPT, hello, my name is Malek, probably gonna say hello, whatever. But if you try it on a base model,
Yeah, it's not in the kind of chat model, it's not like,
exactly, it's not trying to answer my questions or follow my instructions or whatnot. It's basically trying to complete the logical piece of text that would come after this sentence.
Okay, yeah.
After having trained on the whole data set on the
It's
internet.
kind of ritual comes next, yeah.
Exactly. So if you try to think on the internet and you see this sentence, hello, my name is Malek, what comes next probably is something like this. Probably. You can try again. There you go.
You copy alongside the Wikipedia, it's gonna spill out the whole Wikipedia article as is.
It should, let's see. It depends how good it memorizes or how it's optimizing for memorization. So it's not exactly the same as this one, but it sure does look like it. Yeah. And you might think that the base model is completely useless because it doesn't answer our instructions, but if you're clever with the prompt a little bit, let's say, what was my question? It was, give me a valid email address. So if I, instead of giving this prompt, I try to give it this prompt. Let's say one more. What is it? test@hotmail.com. And then another one. If I give it this prompt, I would expect it to somehow try to complete this sequence of text. And maybe now it becomes a little bit more useful. But still, it's still limited. You cannot give it like complex instructions or ask it to debug code or whatnot. And that's where the importance of the next step of the training comes in, which is the post-training. So, during the post-training, we basically take that same model. Yes, you have a question?
How does it know when to stop? In the previous prompt, it stopped it.
Good question. So I said here that it's trained on this whole text, for example, but we add special tokens at the end of each paragraph. These tokens are called the end of sequence tokens, and they look something like this. And that's how it knows to stop. That's how it knows when to stop speaking, because it has been trained on paragraphs that stop speaking at some point when they see that token, the end of sequence token. So if I say here something like, let's see. Hello, my name is Blake. Okay, so it didn't do it here, but if we try a few times, you will see it at the end of sequence token, and that's how it stops producing new tokens. Oh, there you go, end of text. So when the model produces that specific token, end of text, the library stops asking the model to produce more text, basically. So if we go to the post-training phase now, in the post-training, we take that exact same model, the base model that we've seen, and we fine-tune it on conversations. Human assistant, or user assistant. Conversations that look like this. And there are a few open source data sets as well for these kinds of data. So for example, this is an open source data set called Open Assistant, and you can see here the prompter's question is, can you write a short introduction? And the assistant's answer is this here. Now explain it to a dog, etc. And during this phase, we also use other special tokens. And these tokens are here to delimit the start and the end of the user and the assistant message. So, for example, what is 2 plus 2? 2 plus 2 plus 2 plus 2 equals 4. And then I ask it again, what about 2 times 2? So, basically, for this sequence of text, we take that from the data set of training, for example, and we prefix these with user, assistant, user, special tokens that delimit the start and the end of that message. So before the start of the user message, there will be this token here, and at the end there will be this token here, and then before the start of the assistant message, there will be this token here, and so on and so forth. And we take that model, we train it on this whole data set of conversations. This time the data set is a bit smaller than the first one. The first one takes a bit, like maybe a few months to train and maybe millions of dollars of electricity to train. But this data set here, this one is more higher quality data because it has been labeled manually by people. And it's smaller. Maybe it can be trained in a day or two in the big labs. So yes, after this, basically during this post-training phase, we trained the same model on that whole sequence of human assistant. And what we get is a instruct model. That's how they call it, an instruct model. You can call it a post-trained model. Basically, it's to say that it's a model that has been through all of the training phases. These are the kinds of models that you guys are used to. So, ChatGPT, for example. Let's see. What is 2 plus 2? One thing that is special here is that during the training they use those specific tokens to show them where the user message starts, and during the inference as well. So when I send ChatGPT this text, this is not what goes into the model. Behind the scene, OpenAI, they pre-format that text with the specific tokens, like this. So it will look something like this. This is what gets sent to the model, basically. So this chat template here is very important because it lets the model know that it's its turn to answer the question now. So if we try now with this new model that has been post-trained, and by the way, with Hugging Face we can use this apply chat template method to see how it looks. Looks something like this. You can see here the system prompt starts here. You are a helpful assistant, and then the user prompt starts here, which is a hello. So now if we go back and we give that new model the same prompt that we gave it earlier, give me a valid email address. How do you think it will answer?
That's correct.
Do you all agree?
Yes,
Okay. Do you all agree?
Can you repeat what you said?
Yeah, the question is, if we give this prompt here, give me a valid email address, to this post-trained model, this new model, the instruct model, it's the same one by the way, 3.18b, but this time it has been post-trained.
And you have made it like a role, like a chat role?
This is the sequence that goes into.
Post-trained it on email addresses though, right?
Well, we've post-trained it on this type data set, something like this. Where is it? So after this training phase, it's supposed to know that it's supposed to answer questions.
Oh, okay.
You see?
Yeah, okay, so it knows now it's not to predict the next sentence, but it's basically to give an answer.
Yes.
The question is, what is it going to give?
Ideally, as per the post-training, we need to add prefixing before giving it to.
Yes, that's important. That's why if we try inference on it, it will not work. It will behave the same as the first one.
Let's give an example.
No need for example. the prefix tokens are important. That's why. So, as he said, in this run here, the only input that I'm giving to the model is give me a valid email address. And that looks like this. But this is not what the model has been trained on to answer questions. The model has been trained on to see this here to be able to answer questions. So as long as it doesn't see those special tokens, it will continue to behave like a base model. So now if we try again, but this time we apply the chat template, and this time the input looks like this. Give me a valid email address, but it's prefixed with these special tokens, special user tokens, and suffixed with this token here to of the assistant to let it know that it's its turn to complete the text completion. And if we give that to the model, it will answer the question. If we try again, it's going to be consistent. So now if we go on to memory, for example, if my prompt is, my name is Malek, and for inference, this is the answer, nice to meet you, Malek. If during a new inference run, I send it this input here, what is my name? What do you guys think it will answer? Do you know why?
Doesn't have memory.
Yes, but why doesn't it?
Previous context, so I'm worried.
Indeed. If you try this, what is my name? I don't have any information about your name. The idea here is that LLMs are stateless. All they take in input is text, and they output text. They don't think about memory, they don't care about memory, they don't care about any idea of a state or something else. So if you wanted to be able to answer this second question here, what is my name? You want to introduce that same answer here and that same question in the same conversation thread. So we can try this now. I copy paste this. In my second run, looks something like this. And assistant. Go. So as you can see, during the first run, the prompt was, my name is Malek. However, during the second run, the prompt is not what is my name only, it's also the whole conversation thread, which includes my name is Malek, and it includes the assistant's answer itself, nice to meet you, Malek, is there something I can help you with, blah blah. So if you try it this time, it will know your name. So that's how memory works. It's up to the responsibility of the developer to maintain the memory, not the model. Next, it's in memory. It's in tool calling is next here. Before I go on to tool calling, do you have any questions? Is it clear until now? Go.
So what do ChatGPTs, like those big companies, do with memory?
So,
Like, do they limit the memory? Because if they remember every prompt that you've made in the past, then
they don't remember every prompt. But basically, when I say, what is 2 plus 2? Here. And then I say, what about 2 times 2? What basically gets sent the second time to the model is the whole conversation thread, not just my question here. But at some point, it's going to hit a memory limit because the context window is limited. And what ChatGPT does and what other agents do is that they truncate that memory up until a certain point. Or they use other techniques like summarization. For example, when it hits the context limit, they summarize the whole conversation thread. So they lose some context, but at least they still have an idea of what's happened until then. There are other few techniques as well we can talk about.
So when you're in and you go to projects, then
Can you say that?
Projects folder in ChatGPT, or in ChatGPT, that's where you kind of keep the memory in there. Is that?
That's long-term memory. That's a different thing. So this here, we've been talking only about short-term memory. Yeah, long-term memory is a fascinating discussion. We can talk about it in the Q&A as well. So, if there are no other questions, yes.
So to summarize this, the short-term memory it's within the chat in
Yes.
the thread, and then if you go long enough, it'll have to re-summarize. So it'll lose its memory over time.
Exactly. So that's why it's recommended to start a new conversation when you change subjects.
That's why I have to start a new chat.
Yes, that's why.
Yeah, so I'm trying to understand, like, most of these websites have, like, I don't know, token-based or word-based pricing, right? Only tokens are using. So if I'm in the fifth sentence of the conversation, and you're saying that earlier sentences needs to be sent for maintaining context, then I'm thinking that I'm sending one sentence, but the pricing will be for...
Yes, the longer the conversation is, the more pricier it becomes.
Okay.
So if you want, like, if you start a new subject and you want to, if you want to spend less money on tokens, you're better off starting a new conversation. So the input is smaller. So there are other techniques that these model companies do, like caching, for input caching. We can talk about that as well. But still, the longer it is, the more it costs because the input tokens are larger. Yeah. Yes.
What are the differences between models like, let's say, Pro and like Instant, for example, with regard to how they approach prompts? Like, are their training vastly different from each other, or is it just the token windows? Like, what really goes on in the back end to make the output so starkly different?
Yeah, the training techniques are different, the architectures are different, and some of them have more training phases after the post-training. Then some of them have reinforcement learning phases, and these are maybe reasoning models. You see them like thinking before answering you. We can talk about that as well during the Q&A, sure. So if you go on to toCalls, now if you want to make the model able to call our function getWeather, the function that we made earlier, getWeather, there's a way to make this model able to call that function. And basically, we tell it how to do it in the system prompt. So here, the system prompt that I wrote is, you are a helpful assistant, you have access to the following tools, getWeather, and I give a description of what the tool does, gets the current weather in a given location, and I say, the way you use tools is by specifying a JSON blob inside a tool called XML snippet. So basically I'm showing it an example here of how to call tools. And this is just the format that I decided as the developer. So I'm giving it an example. I'm telling it if you want to get the weather for New York, what you want to do is write this XML snippet here and write a JSON inside of it. And you would want to write the tool name, getWeather, and the parameter you want to give to that tool, which would be location, New York. And here I'm going to be asking it to answer in a very specific format. I say, always use this format to answer a user query. First, I want you to write a thought. Maybe you should do some reasoning about how to use your tool. Then, if you want to use a tool, this is where you would put your tool call here, like this. Then I want you to write a tool result. Maybe you would do some more reasoning over that result that you got. And then you give me the final answer. So this is going to be my system prompt here. And my user prompt will be, what's the weather in Montreal? So if we see how it gets formatted, we see that the system prompt starts here with all of these special tokens. You are a helpful assistant, you have access to the following tools, all of the system prompt that we read together right now, up until this point here. And then there's the user prompt that starts here, and the user question, which is, what's the weather in Montreal? Now if I give this prompt to the model, do you see something that is off? Do you notice something that's off with this answer?
You don't have something listening for the XML or it's just speaking, you know.
That's true. So if we read the text that it answered here, it made a thought. That's what I asked it to do. So up until here it's good. Then it made a tool call, get weather with location Montreal, which is all good. Then there's a tool result. Then there's a thought here to do reasoning over that tool result. And then there's the final answer.
Did it even run? Did it even run? Or just
Sorry?
did the tool call happen actually? Did it even run?
Yeah, so that's the question. Is the temperature in Montreal really 0 right now? Temperature in Montreal, minus 17. That's why I came to Singapore.
Minus 17.
Yes.
I mean,
Yes.
it is Celsius.
Huh?
It's not Celsius, right?
That's crazy.
I know, it is crazy. You can't walk outside. It's crazy. So,
Yeah.
basically the model here completely hallucinated this tool result. It's not a true tool result. It came up with it on the spot, and it's a hallucination. Now, if you think about it, is it really the model's fault? No, sure. Good answer. It's not really the model's fault because I promised it here in my system prompt. I made a promise. I said, true result here, we will include the result of the tool call that you made. That was my promise. But I didn't do that. I didn't go execute the tool. I didn't give it the true result. So it made it up. So you might think, how can we do that? The way to do this is, what you want is the model to start answering and get up to the point where it makes that tool call and stop it and not let it continue generating more text. That's where you as the developer, you go and execute that tool, you give the result back to the model and let it run inference again. And you can do this with Hugging Face by using a stopping criteria. And here my stopping criteria will be this token, this specific token here, tool call. So basically what I'm saying is, as soon as the model produces this specific token, stop inference, don't do anything else. And if we use that stopping criteria and run inference again, this time it's a thought, get the current weather in Montreal, makes its tool call, and we're stopping it here. Now, as a developer, I can go and execute that tool. So just for a moment, I'm gonna save this text here into a Python variable so we can use it later. And I can go and execute the tool. So I see that the parameter it wants to give to my weather function is Montreal. So I go and execute the weather function with Montreal as a parameter. And this is the result that we get from our function. It's the same function as earlier, by the way. Just makes a few API calls to get the weather. But the answer looks like this. Dictionary containing a lot of information, but we just want to get a temperature, for example. So after doing this and after getting the tool result, we want to do another inference run. We want to use the model again. You have a question?
Yeah, it's just a quick technique. So when you say stopping inference, and is it kind of like putting it on hold into the GPU and just externally get cache in there for the inference, and you just bring it hold and you continue from there? It's a polling inference when you can follow up after the.
It's a very simple idea. The idea is that the model produces token by token.
Yeah.
And so we basically, to produce 3 tokens, we run inference on the model 3 times. But what we're doing in the stopping criteria is, as soon as this specific token is outputted, don't run inferences another time. That's about it,
Okay.
basically. Yeah. So we ran the tool, get weather, we got this result, and now what we can do is we can go back to the model, and give it that exact same system prompt as earlier, the exact same user prompt as earlier, but also we give it the fact that it, as an assistant, had already started outputting something, which is the last model output. This is the variable that I saved earlier, which is this. So I'm giving this in the input to the model, and I'm appending to it to result the result of get weather, basically. So if I run this chat template to see what it looks like, this is what's gonna go in the model this time, like the second time around. So the first time, my input was simply, what was it? The first time my input was simply this, or the whole system prompt and the user prompt, which is what's the weather in Montreal. But now the second time around, my input is the whole system prompt again, the user prompt again, but also the assistant prompt, not the prompt, but the assistant output. Thought to get the current weather, that's what I wrote earlier. And then I'm appending to that the true result, and I'm giving all of this back to the model. And now it's supposed to autocomplete, and it's making a new thought. That's what I had asked it to do in the system prompt. And then there's a true result. Here it's hallucinated something, so this is not working well.
Did you call it the assistant prompt?
The assistant output, sorry. So if we try this again, sometimes these models make mistakes because I'm using a small model, which is Llama 3.9 8B. So if we try this again, this time around it works. So it had seen the true result here in the input, then it made a thought, and then there's a final answer. Ah, yeah. Yes. So that's how it works. Tool calling is also up to the responsibility of the developer, not the model itself. The model will still just output text as text tokens, but the developer or the library around it goes and parses that text, executes the tool calls that the model wants to make, get the result back in the form of text again, give it back to the model, and run inference again. Any questions?
Good.
Yes?
Why are we doing the last one?
So if you want to get, let's see, if you want to get this whole thing as the user, you don't need to get the last prompt. But if I only want to get the temperature, then I want the model to go read that output for me and synthesize it and get only the temperature for me. You get the idea? So as the user, when I ask my model, hey, what's the temperature in Montreal? I don't want to get this whole thing back as an answer.
Yeah, I understand. I'm trying to think that I'm giving the whole output and then I'm getting the response back, which has a chance of hallucination. I'm thinking like I have an accurate result from the tool call already. So why I can't just have some kind of placeholder, like say $, wherever the temperature is needed, just place some kind of $, and then I will manually like replace it. That result will be highly accurate.
That's when you know what the question is. So if you already know beforehand that the question is what's the temperature, then yeah, I mean, you can parse to automatically get the temperature. But what if the question is what's the elevation in Montreal? That's something different. So you want the model to be able to have the agency to choose what to give you back from the output. So yes, my favorite scientist, Richard Feynman, says, what I cannot create, I do not understand. So we'll be implementing an agent from scratch. It will be the equivalent of the agent that we saw earlier with Pydantic, but without using any frameworks. So this is what I'm going to be using here. And basically, with this code here, it's agent from scratch. Fine. If I tell it, hello, my name is Malek. and then I ask it, what's my name? Doesn't have memory. That's the first thing. And if I don't, what's the weather in Montreal? Get access data as well. So the first thing that we're going to be implementing in our agent will be memory and then tool calling. And before we start, I'm going to show you, I'm going to try to read the code quickly for you so you get an idea of what's already in here. I'm starting with the imports. I'm initializing my client object for OpenAI. I'm using OpenRouter, by the way. It's a router. It's a service that routes you to any model you want. And the model that I'm going to be using is Claude Opus 4.5. We have this function here, get weather, takes a location as a parameter. We have the system prompt. This time around in the system prompt, I'm doing something special. I'm asking it to always output JSON. Always. Even if its output, even if it doesn't want to make a tool call, the output will always be JSON. So I'm telling it here, you answer only in this JSON format, and if your intent is to message user and wait, then you would write it in this way, and you write your message like this, and I would parse it myself. And the reason why I'm doing this specifically is because it makes it easier later to implement tool calling, so for pedagogical reasons. Then we have the agent loop function, and for this, I'm gonna be doing breakpoint debugging just to make it clearer. Let's see. It's working. So we start here. We get the user input, and if we go to the next line, this is me giving the user input, which will be hello. My name is Malek. We save that user input into a Python variable, user input here, and then we call the agent loop function with that user input in as a parameter. And if you put a breakpoint here, let me move this. Let me try this again. Here are the file counters, we can ignore these. Hello, my name is Blake. And we get an argument prompt which contains the same user input. Hello, my name is Malek. And here I'm just basically writing that prompt into a file so we can debug them later. And then I'm calling the model. I'm using just the shot completions API, which just makes an API call to OpenRouter for inference. And I'm giving it the system prompt and the user prompt here. So if you execute that, you get a response. The response looks like this. And then at some point I'm going to be parsing that response. So this was the response, intent, message user and wait. The message is, hello Malek, nice to meet you. How can I help you today? And I'm going to load that into a Python dictionary. So keys, intent and message, values, message user and wait, and the message itself. Then I'm going to be writing that again into a file just for debugging purposes. Then from that dictionary, I'm going to be returning only the value of message, which is hello Malek. If I do that and print it, we see the output here. So that's what we're starting with. And now, if we want to give it memory, what would be our first step? Have any ideas?
You have the contents of the file back to the. You have the contents of the file when you're storing the conversation.
Oh, I'm not storing these in a file. This is just for debugging purposes, so you can ignore this
You
here.
just add the prompts to the next prompt, or add the previous conversation to the next prompt.
Yes, exactly. How can we do this in Python?
You have local array. That's all. That's happening.
Array?
The output array.
Yes, array is a good data structure for this. Some people say dictionary. Dictionary will not be good because it doesn't keep track of the order, and you would lose the order of the conversation. So array is a better data structure for this, and we can initialize the array here. In Python there's no array, it's a list. Same thing, dynamic array. And conversation thread will be a global Python variable, and so it will be accessible inside the function if we need to. And my first step will be to put the user input in my array, basically. So in my list, conversation thread dot append user input, and we can put the user input as is, but we can also pre-format it something like this: role, user, and then message user input. So that's the first step. What will be the next step?
And the result of the development at the end, so we actually at 12.
Before we go to the result of the model, here we're putting the user input inside this Python list, but we're not using this list anywhere else. So basically, since this will be a global variable, we don't need to give this user input as a parameter, and we can remove this argument here. And for prompt, we can get it basically from the conversation thread. Something like this. It will be json.dumps, I think, to take that dictionary and transform it to a string that we can send to the model. So, what next?
Just also pending the agent's response after the users. First, we're just making sure that the whole conversation thread is the backup for the assistant and us.
Yes, indeed. So we have the LLM's response here. We're gonna be appending that to the conversation thread. So we can put something like this: role assistant. Something that's more descriptive than a message would be action, because it feels like an action here. So action, LLM response. Is this enough for memory?
You should use the conversation thread. You should use it.
We're using it here. So if we try this, let's see, apply. Hello, my name is Malik. And if I delete these 3 files just for debugging purposes. Hello, my name is Malik. We see that the first inference time, the prompt that's sent to the LLM is this: hello, my name is Malik. And the response is, hello Malik, nice to meet you. And then if I tell it, what's my name? And the second time around, we're giving this to the LLM. So, my first question, its own answer. And then my second question. And then we see the response here, which is hello, well, your name is Malik, as you told me. So that's for memory, that's good for memory. Next step would be tool calling. Do you have an idea of what would be the first step to implement tool calling? Like to give it the ability to call our tool here, which is get weather, and get the temperature for us if we need to.
You have to change the system prompt.
Yes. Good point. Change the system prompt. And now it's not going to be that difficult to write because it's already supposed to output a JSON. So I can tell it if your intent is message user and wait, well, you want to write a message. But if your intent is different, let's say get weather, then you would want to write a location parameter, your location here. Makes sense?
But you didn't tell him this is a tool. Get weather is a tool in my
Yes, I didn't need to. I could, but I don't need to because it's clear that its output is supposed to be JSON anyway. So if it follows my first instruction here, which is please output a JSON format, then I don't care if it knows if it's a tool or not. Also, I'm using Cloud Opus, which knows what basically actions are. It knows that it's a tool and it's already been trained on this kind of things. So this should work as a system prompt.
Question.
Yes.
So since all of this is referential, right, the answers are going to be within set parameters that we're defining in the development of this region. How can we prevent hallucinations from happening like it did with the last question, what's the weather in Montreal, it's at 0? Is there any way to embed like hard stops to absolutely negate any possibility of it hallucinating when we're adding the true column after the memory? Or like if it gets a question outside parameters, it will hallucinate. That's inevitable.
But hallucination is still a possibility that you can't bring the probability of a hallucination to 0. It will never be 0.
Yeah, it might even like, I mean, it sometimes even doesn't do the JSON, right? Like, it might
Yes,
like,
exactly. So sometimes it will not do the JSON format. So this solution is probably not robust because sometimes it will like write a different format. Yes.
Yeah.
This is good for pedagogical reasons, but then if you want to bring this to production, you would want to think about how to make it robust. In fact, it's one of the homework questions that I have for you if you want to explore later. So after this step, after modifying the system prompt, what will be the next step?
I think it's cool. I think it's cool.
The stopping criteria?
Yeah, criteria.
So in this case, the stopping criteria is already, let's see. I'm not going to be needing a stopping criteria here because all I'm asking it is to output a JSON.
You just need to pass the get whether you code.
Yes,
Yeah, you code, just do another code, right?
yes, that's true. How can we do this here in Python? So if you think about it, now given this system prompt, the output will be something different. If we ask it for the weather, it will not be message user and wait, it will be something else.
Yeah, so after the response, we need to like
React based on the intent. So basically here, I'm assuming that the intent is going to be message user and wait. Let me fix that. So we want to return only if LM response, the intent is message user and wait. What is it? So I didn't change a single thing here. It's the same code doing the same behavior. But now it just checks if the intended message user and wait. So now, as you said, we want to check for the different intents, right? So let's see. If the intent is message user and wait, we're going to be returning. But if it's get weather, then we do what? We call the function get weather here with what parameter? Location, which would be the value of the key location. So LM response. We're assuming that the key location will be there, and basically yes. You want to store it in a variable, get weather result maybe. But next.
Before we issue the get results.
Another system prompt that's delivered.
It's going to be the same system prompt.
I mean, I think you just leave it everything again.
Yes, how can you do this here in Python?
I mean, you just need to body check to forget like something. Just need to call the same function again.
Good point. Would you do it recursively like this?
We can do another intent that deliver as third agent.
We'll be using the same agent.
You could do some sort of loop, right? Like until and unless it returns a message user and wait, we keep calling agent loop.
Yes, that's the right way to do it. In fact, the hint that I gave here is the name, the function name.
Oh yeah.
It's an agent loop. So there's a loop somewhere. But before we even go to the loop, like if we tell me where would you put the loop?
Somewhere else. Somewhere outside.
Yes. So the idea here is to put the loop on the whole function. Yes. Wow, true. The whole thing will go inside the loop. There it is. Will this work? There's something missing. We're breaking here. We're assuming that we're given the responsibility of breaking to the model. But however, something is missing here.
Or we aren't tracking it, we get whether result back to the array.
Exactly. The get weather result, we're getting it from the function, but we're not using it anywhere. So how would we use it?
We can just add it to the list.
Yes, the conversation thread. So it can go in the same list here, conversation thread.append. We'll call it something like get weather result. Get weather result. All good?
No, we have to add it to the agent. Oh, you're doing the loop, so I think this is all.
So the idea is that this famous while loop here, it will take care of basically the first run. The first run, my question is, what's the weather in Montreal? In the first run, the model will say, hey, my intent is to get weather. And we'll go execute that get weather function. We'll append the get weather result in the conversation thread. But then what else next? Next, we go back to the second iteration of the while loop. This time around, we use that same conversation thread list and we send that back into the model. This time it will contain the result of the get weather and it will see what's the result, and its intent this time will be different. It will be, instead of get weather, it will be message user and wait. So if we try this, agent from scratch, mistake. Let me delete those two. Delete. Go. What is the weather in Montreal? See, this is the first input. The output is intent get weather. This was the first iteration of the while loop. Now there's a second iteration of the while loop. But this time, the input is this. What's the weather in Montreal? The assistant action get weather. The get weather result itself. And the intent of the model, which is message user and wait. And thus we return from the function, and this is what's outputted here. And just like that, in 100 lines of code, we have an agent that is able to, has memory, that is able to call tools. And in fact, it's easy to generalize. So if you want to add other tools to the agent, it will use the same while loop. So basically, here, if I want to give it a new tool instead of get weather, I want to also give it the tool get location, so that I don't have to specify Montreal every time. I can add this new tool here. So let me see. I'm going to use Klein here, by the way. Klein with what model? Gemini 3. Let's see. Let's say Cloud. Opus. And I'm going to ask it in agent scratch apply, add a new tool, get location, which returns a hard coded Montreal. In fact, Klein is an agent, so it's going to be using tool. So here, to add a new get location, whatever, Klein wants to read this file. This is a tool call that this agent made. The tool is named probably read file or something like that. And when it uses that tool, and it gets gets as an input all of the text, all of the code that is inside that specific file, and then it's using a different tool, edit, to edit the content of that file. So here it added a new function, get location, and it's adding this handling here, which is good as well. Approve. So this was good, but it forgot to modify the system prompt as well. So if I say or get location, there we go. So now, since my agent has access to two tools that it can use at the same time, I don't need to give it the location again. So my question can be, instead of what is the weather in Montreal, it can be what is the weather now. Not this one. Agent.scratch. What is the weather now? So the first time, can you tell me the location? Okay, so it's not using that same, maybe, let's see. English from scratch. Let's try again. Maybe if it's clever this time, it will know that it can use the tool get location. So this time it worked, I think. So this was my input, its output is get location. This was the first iteration of the loop. Second iteration, after it got that answer, which was Montreal. Second iteration is get weather, Montreal. And then the third iteration, the message itself. And that's how it works. That's about it for this section of coding the agent by itself. The next thing I have here on the slides, I have this meme here. Agents, wait, it's just a loop, always has been. It's just a while loop, basically. You can give it like 100 tools and it will work in the same while loop. It's pretty simple. And other agents in the wild. Here I have Klein. Klein is an open source version of Cursor a little bit, so its code is open source. We can go see it. In fact, if we go Klein, I have the code base here. And if we go to the system prompt, we can see the system prompt that it uses. And by the way, this is the system prompt that Klein uses. This whole thing. So we see, we start with Klein, you are a highly skilled software engineer. Tool use is telling it how to call tools, and these are the tools that it's given it. So execute command to execute commands at the terminal. This is an example, but these are the tools here. Read file, it was the tool that I used earlier to read the file. There's write to a file, the tool that I used earlier to write code. There's replace in file, search files. There are many tools that it uses, but this is about it. And then later, it's got information about MCP tools, which are a bit different. And it's got a few rules. avoid some back and forth conversation, only ask for necessary info, etc. Act mode versus plan mode, capabilities, what you can do. So this is very cool if you want to read it. I myself read the whole thing, and it helped me write better prompts in my products, in my agents. ChatGPT is an agent as well. When I ask it, let's see. When I ask it what's the weather in Malaysia right now. So you can see a version of its thinking. I need to look up the weather for Kuala Lumpur. At some point here, we don't see it, but I made a tutorial to use the web. I made a web search to get the weather of Malaysia. And what else here do you have? Cursor is an agent as well. So on and so forth. So that's about it for the class. We did an example of what's an agent, LLM fundamentals, the memory tool calling, how to code an agent from scratch. The next step would be to code the agent by yourself. If you want to get an even deeper understanding, you would want to think about how to make it more robust, because you can't assume that the LLM will output the correct JSON format every time. And maybe make it use the user assistant format, because I haven't been using it. By the way, this is another detail in this demo app here, which is I haven't been given the model user assistant. So if we see here, this could be the format that you use, but you can also use this format. Instead of giving user assistant, you can just give the system prompt, and then the user prompt would contain the whole conversation thread. This is the conversation thread, user message, user assistant message, etc. And that's what I have been using by myself for this app. But you can use the other one, maybe think about how to do it yourself. And that's about it. Q&A. Any questions? Yes?
What's the difference between no-code tools like N8N and this approach of when I use it?
So, you can think of it as different levels of abstraction. The level of abstraction that we went to right now is the lowest one, in the way that we, especially during the first part of the workshop, we used, let's see, during this here, the whole thing here, we've been using like stopping criteria to parse these things ourselves, etc. This is the lowest level of abstraction, and you don't need to go that deep. In your code, if you're making agents in your code, you'll probably use some agent libraries like Pydantic, this one here. So this is an abstraction that has the whole magic behind it here. But if you want to go an abstraction layer that is even higher, then N8N is something for you. Then with N8N you don't even write code. You manage them like by the UI that it gives you. I've never tried N8N, but basically it's an even higher level of abstraction if you don't want to write code, basically. Again, with these things, the lower you go in the layers of abstraction, the more control you have. So if you use N8N, you will find limitations.
This is what happened, it's just a loop as well, just with different tool calls and different tools waiting after each other, right? So in the end, there is also an orchestrator like an agent like this, which is just making the loop, like any flow, you have a certain numbers of tasks that you're waiting for.
This is for N8N?
Yeah.
Okay.
Let's putting a similar thing with this, and it happens high level. Like that's also like a loop with the steps it has.
Okay.
So basically what you're saying, you use Cline, and then you can also use open source models, right?
Yes.
And so you can
Yes.
For some applications or some use cases, you use an open source model, so you don't have to pay for tokens for it.
Yes.
Yeah.
So Klein here, we can use the OpenRouter API, which gives us all of the possible models here. If you look at Klein, if you look at OpenRouter, this is it basically routes you to different inference providers. So if you use Claude, for example, it will basically route you to the Claude API. So you see here the providers are only Anthropic and Google Vertex. But if you use something like, let's say, Qwen, an open source model, this one here, well, it will route you to other inference providers that are also basically just loading that same model, the open source model, and running inference on it. And there are many other inference providers. So now, if you want to use your own inference engine, something like VLLM, I don't know if you've heard of it, but if you want to run your own local model on your own GPUs, then you can use Klein for that as well. And instead of using OpenRouter as their provider, you can use an OpenAI compatible API and give it the URL of your own thing. So if you're going to be running inference on your own GPUs, you're going to be exposing it over an API. It will have a URL or an IP address at least, and you would use that and it would work same way.
Did you say you guys are running models locally?
Yes. So in our company, we try to keep all of the data, all of the confidential data local, and even the code we keep it local, and we don't want to send our information to other like APIs and other providers. So we use our own local models. We have a few GPUs, and currently we run Qwen on it, Qwen 3 coder, which is a pretty good model. Not as good as Cloud 4.5, but good enough.
You guys done any post training on that, or is it just?
No, you just take the model that has been post-trained, open source. We use that same model. It's good enough for most of our use cases. If we find that it's lacking in some specific area, you can try other models. If they're all lacking, maybe we can think of fine-tuning it, etc. Yeah.
It's interesting, if this trend is kind of higher level than this, but if this trend continues, then the freer models, or the open source models, become more and more powerful, right?
As of right now, the current let's see, for 8 billion parameter models, so the smaller ones that are able to fit in this very small GPU relatively, 2 years ago they were not even able to make tool calls or act as an agent or whatnot. They were too weak. But now they are perfectly capable, and they are even more powerful than GPT 3.5. Some of them, like there are 20 billion parameter models that are even more powerful than GPT-4 and GPT-4o as well. So yes, if you look at the trend, the model weights are, the model sizes are going lower, and it's getting more and more democratized. So people who have GPUs will be able to run inference locally, and even on your phones probably in a few years you'll be able to run some models, maybe 4 billion parameter models on your phones directly.
So yeah, this is like one of these points is it's decentralizing because like the open source models are maybe like 3 or 6 months behind.
Yeah. So once the private models plateau, then the open source models can catch up, and you know, like this is the argument that these models they're going to be on the cloud now. There's going to be no defensibility. I mean, the money will be made in the application, right? Customization for the use case.
But you said if this trend continues,
Yeah.
I think there's going to be, if this trend is going to continue, but then you said when the commercial one is plateau,
Yeah.
why would they plateau and not get anything in the next quarter?
Well,
This is a finite amount of data.
yeah, well, even if it doesn't
There's a finite
plateau,
amount of text, but there's not a finite amount of raw information. Now we're moving into multi-model, so
if the models don't plateau, the rate of change.
Next is,
So there needs to be new models, right?
yeah, but have you used Gemini multimodal on video and images, on real life? It's a real.
Okay.
No, I'm just, I'm saying that maybe it will plateau. There are trillions of dollars being invested, assuming that they're going to go.
But David, even if they don't plateau, the rate of change can plateau. So the gap is
Yeah,
closing
the
up.
gap will close.
The gap between open source models, at first it was like 9-month gap. Now it's maybe a few weeks. Maybe at some point it will be equal.
Because Opus,
Maybe.
this Opus 4.5 is insane, right?
It's insane, yes.
And so it's going to be free in whatever, a couple of months, right?
Yes, we will get an open source equivalent of 4.5 in a few weeks, a few months. For sure, for sure.
What's crazy for me, we just tried the QEK2 thinking.
Communicative thinking, yes. Good, good one.
On basically just, I'm not sure if you heard about it, QEK2 thinking is a Moonshot, a Chinese company. And you can just put them locally onto Mac studios. So you can run them in a decent speed. You cannot get multiple users for decent speed, but for your own and maybe two of you can really use it.
What's that for? Coding?
It's a general thinking model for reasoning, so you can. I think it's on par with GPT-5 on.
Yes, so you mentioned QEK2 thinking. Here, there's this website called Artificial Analysis, which shows you the different benchmarks that you can look at. And if we look at a few benchmarks, QEK2 thinking comes on top actually. So the Bench Telecom Agentic Tool Use benchmark, QEK2 thinking is on par with Grok, and it's even better than 4.5. In this specific benchmark, it's not, but we see it's pretty close to the frontier models, very, very close. Let's see.
But can you just say again what that is?
This is the QEK2 thinking. It's an open source model, a trillion parameter, and it's here. So on the most general benchmark, like an aggregate of all benchmarks, it's up here, right between like GPT 5.1 and 5.1 codecs. So it's pretty close, basically.
And you can run it at home. So you
Yes.
can run it in 2 Mac Studios, maxed out for like 20K. You can run it locally. And basically you have something that's beating GPT-5, right?
Yep.
So,
In some use cases, yeah. It's a 1 trillion parameter model, but it's quantized to 4 bits. So the memory that it consumes, that you need, the VRAM that you need in your GPUs would be something around 600 gigabytes of RAM. So if you can afford 600 gigabytes of VRAM, you can run QEK2 thinking. Maybe 800 to have more bandwidth for the context. But yeah, you would get pretty close to frontier performance with this model. Yes?
Yeah, if you use an API for there's some alternatives to it.
Can you say that again? Sorry.
Yeah, if you don't use an API, you don't have a good computer. There's good alternatives to you can have locally but not use device.
So you can rent GPU. Instead of buying your data is sensitive, you probably would not trust it. I would rent.
You can run the 8 gigabytes on normal labs.
The 8 gigabytes model, the 8 billion RAM.
8 billion parameters.
Yes, on normal Macs you can run 8 billion. On this Mac here, it's a 128 gigabytes of RAM. So you can run maybe 200 billion parameter models quantized. So which is good. You get like a 5K MacBook, you can run some of the biggest models. However, it's slower on MacBooks than on NVIDIA GPUs. Of course, NVIDIA GPUs are more optimized for performance.
You get faster responses.
From NVIDIA. Oh, from local, you get faster. You're gonna be getting the same response that you get from something like OpenRouter. Though it depends on your GPUs. If your GPUs are not performant, then yeah, you're gonna be slower.
But if you get the same kind of GPUs that all the interface providers use, then there's no reason for getting like slower responses. Yes.
How do you think of internet use versus Google calls? Like, for like something like get weather, would you write a Google call or would you just ask me to use the internet?
For something, okay, so it's a good question. It depends. It depends how generalized your agent you want it to be. If you want it to be able to do many different things that you cannot even imagine, then probably you want to give it the web search. But if you know that the only kinds of tools that it should use is to get the weather, then I would use a specific tool myself. Any other questions? Maybe one like a small bonus for those of you who heard of MCP. You've heard of it?
Yes.
Yes? MCP, like an MCP server, all it is really is just a tool, except that this get weather tool, we're running it in the same code base. But what happens if what do you do if you want to call a tool that is living in something else, somewhere else, in another country, another server? MCP is just a protocol to give a standard to call these outsider tools, basically. So MCP, it got a lot of hype like a year ago, but it didn't provide something new. Tool calling has been there for like more than almost 2 years and a half now. So that's about it. Any other questions before we?
It's really great.
Yes,
Yeah.
you loved it.
Very good.
Nice.
Very informative.
Thank you.